Yeah. And it's always, they last 2 minutes play, they play it.
Yeah. I bet that Belichick's a hell of a chess player.
Hey guys, I'm trying to pull up the review on so that everybody can look at it. The one that we were going to do in Math Lab. So bear with me. Does everybody have theirs? Okay, good. Okay, so here I go. Hopefully it downloaded okay. 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 Do I have any people that are willing to talk in there if I ask questions? Or is everybody going to be shy? Okay. Just to kind of see where everybody is. The first two on here are from 5.2. They're very general, more of the simple rational functions. So on those, what we talked about in class, we had this particular formula where the horizontal asymptote and the vertical asymptote, where the horizontal was the y equals k and the vertical was x equals h. So that being said, who can tell me, because this was where, and Miss Stone's on here with me. Miss Stone, I was focusing with my group, and I think you were as well, the horizontal and vertical asymptotes. So that's where I wanted to start.
Sounds good.
Does that sound good?
Yes, ma'am.
Okay. So who can tell me, based on that, what would the horizontal asymptote be for this particular graph? And I can't see the chat window when I'm on here. So either somebody needs to speak up or somebody needs to tell me if somebody else writes it in the chat window.
Is the horizontal on the bottom or the top?
The horizontal, the HA, is the y equals k. So it's going to be this part of the formula. So what up here would identify with this right here?
-1, right?
Yes, good job. Way to go. So the horizontal asymptote on this particular one is going to be y equals -1. So that would be graphed. We do that with dotted lines, and that's going to be graphed. And y'all will just have to excuse me. It's really hard to write on this sometimes. That's a dotted line, believe it or not. Okay. All right. So the vertical asymptote then would be the denominator in this case, the x minus h. So when you're pulling it out, you got to remember that the original equation is x minus h. So what would the vertical asymptote be? Anybody write anything? Oh, Sam. Yes, I switched back. Sam said -2. Yes, that's absolutely correct. X equals -2. Oh, and Miss Stone, I don't know if you can tell who's in there, but I do want to take note of everybody that's in here today.
Yes, I'll write it down.
Okay. X equals -2. So then I'm going to draw my line. And once again, please excuse it. Through there. So now you would just basically draw your curves, and the curve goes along the asymptotes, but never touches. And you can, if you want to, do a little T-chart to make sure that you've got some exact ones. I know on this particular one, this goes through the origin for sure. And that's not, it's kind of shaky writing on here, but, and then I also know that 4 and -2 are one of the points, but you can do a T-chart and get some exact points if you want to. And that's probably this one. This right here was not. Not very good. There we go. Maybe a little better. It's a little hard writing on that, but that's the shape of it. Are there any questions about that? Does that clarify things for people? And Miss Stone, if you'll kind of keep watch on the chat bar in case somebody does ask me a question while I'm in the other.
Will do.
All right. Does this, and Miss Stone, does this present pretty well? I mean, do you see it? Do you see the screen okay? What's your
Yes,
take
it
on
looks good. It does. It's good.
Okay. All right. So for the next one, based on exactly how we did the prior one, what is the horizontal asymptote going to be? HA. Any volunteers?
That one's going to be 1.
Yes, y equals 1. Thank you. Okay, so all right, how about the vertical asymptote?
Yes, that's correct. -2 is correct. Good job, guys.
Okay, thank you. Good job. There we go. And Mrs. Sparks's drawing skills are on the line here. Now, the first one, you saw that the primary graph was in quadrant 1 and 3. Because there's a negative sign in front of this one, we're going to do the inverse of that, and the drawing, the graph is going to lie in quadrants 2 and 4. It's going to be inversed. And once again, you can do a T-chart and, have some exact. Did I draw that right? Oh, I didn't. Oh. No one caught that. Probably because it's hard to see. Okay. Any questions so far? Everybody feel pretty good about the simple ones? All right. Now, on the more complicated ones, this is 5.3. We gave out a sheet that talked about the horizontal asymptotes. And we also, the very first thing it said to do is factor when you're graphing these more complicated ones. And it also talked about the horizontal asymptotes, where you do a comparison of the degrees at the top and the bottom. And by degree, you're talking about the exponent up here and the exponent down here. So the exponent in this case at the top is greater than the exponent in the denominator. So when the exponent in the numerator is greater than the one in the denominator, then there is no horizontal asymptote. All right. Now, we need to factor the top. So I know we can factor out an x. And that leaves us with x squared minus x minus 2. And then that factors further to be x minus 2, x plus 1. And how I know that is I'm looking for whatever multiplies to be a -2 when the same factors are combined will give you a -1. And -2 times a +1 gives me a -2. And when I add them, -2 plus 1 gives me a -1. So that's how you do that. And then on the bottom, if I factor that, I'm going to factor a 4x out. And that's going to leave me with x minus 3. So for my vertical asymptotes, you're looking for anything that will make the denominator a 0. And in this case, you've got 4x and x minus 3. But the x from here cancels with the x from here. So that actually creates a hole and not an asymptote. And you'll get to learn more about that next year with Miss Stone. For our purposes in here, we're looking for asymptotes. So you would set that bottom factor equal to 0, and that will give you your vertical asymptote. So in this particular case, we have no horizontal asymptote, and we have a vertical asymptote at 3. And then there's this hole that's created right there And it actually falls on the origin, but your graph looks like, well, it doesn't look quite like that, but I'm not the greatest drawer. Especially on this screen. Ms. Stone, is there anything that you would want to add to this? Or have them know, or something that I missed out or forgot?
Nope, that looks good.
Okay. Do you even think that graph looks great?
Yes, it's beautiful.
Thank you. Is there any questions? Did anybody type anything that I missed? And am I racing that too quick? I hope everybody got it. Okay. All right. I think I should let them do this number 4. Tell me what to do. Who's going to help me do number 4? Okay, Mo, you can. I'll let you. I'm sure she did. Any talkers, or is there any typers, Miss Stone?
No, they're being quiet.
Okay. All right. Well, let's ask specific questions. Okay. For the horizontal asymptote, you want to look at your numerator and your denominator. If the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then you would take the ratio of the coefficients. It's really hard to write on this. Okay. If the numerator is less than the denominator, then the horizontal asymptote equals 0. So let's just take a look at it. What is the degree of the numerator? What is understood that x is raised to? What is that?
Good job. That is right. They said 1.
1. Okay. So what is the degree of the denominator? What is that x raised to?
And they're saying 2. Good job, guys.
Good job. So the numerator is less than the denominator. So it falls into this category. So what would your horizontal asymptote be? Anybody answer?
They're saying 0.
Good job.
Yep. Good job, guys.
Okay. So now we've got our horizontal asymptote and it falls at 0. So y equals 0, which would just be along there. Now, our vertical asymptotes, you want to factor the denominator. So that would look like, should I let them do this, Ms. Stone?
Yeah, that sounds good. Let them do it.
All right.
Yeah.
See if anybody comes back.
Okay, we have a couple saying the vertical asymptotes
are
3 and -3.
Good job.
Good job, guys.
Real good. Awesome. Okay.
And James put the correct way to factor. Good job.
So how it looks factored is you would take a 3 out, and that leaves you with x squared minus 9. And that's the difference of 2 squares, which looks like x minus 3 and x plus 3. so that you set each of those factors equal to 0. So that gives you your two horizontal asymptotes of x equals 3 and x equals -3. So you would draw those. And then you would draw your graph because it goes along your curves. Anything else that you want to add, Ms. Stone?
Nope, that was good.
Okay. Does everybody have everything down that they want to write down for that? Can I move on? Are there any questions? Do you see? All right.
No questions. They're ready.
Okay, moving right along. Okay. So for the horizontal asymptote, once again, we're going to compare the degree of the top and the degree of the bottom, the numerator and the denominator. So what's the understood degree at the top? Do we get anything back, Ms. Stone?
They're saying 1.
Oh, okay. All right.
Yep.
And then at the bottom, it's what?
They're saying 1 again.
Okay. So the degrees are the same. So now what do I do? If the degrees are the same, what do we do? Oh. Okay. Does anybody know what to do from here? Can you compare? Okay. Can you hear anything, Miss Stone?
Yes, I can hear. Yes.
Okay. Because somebody was saying they couldn't hear anything. So I wasn't really sure if they just don't know what to do at this point, if they need me to walk them through it.
Madeline, do you have everything worked out? Can you hear us?
Okay. Oh, good job, Alyssa. Okay. She knew to take the ratio of the coefficient. So that means you're going to take, you compare the degree of that leading coefficient, and then you take the degree of the leading term, and then you take the coefficient of the leading term, which the top is -2. And the bottom, there's an understood 1. So it's -2. So that means the horizontal asymptote is y equals -2. Now the vertical asymptote is whatever is going to make that denominator a 0, because it's still not okay to have a 0 in the denominator.
Miss Sparks,
Yes.
we still have someone who can't hear. Can you walk us through the steps of how she can turn her mic on?
Yes. Can they hear me now?
No, I don't think she can hear.
Oh, not at all?
Mm-mm.
Huh. Sometimes if they leave and come back, it works okay. And sometimes if they mute and unmute. Okay.
Okay, I'm gonna text him. I'm texting him in the chat box. You can go ahead.
Okay.
Okay.
All right. Because I do want them to be able to hear this.
Okay.
So maybe I should I don't know. I'll circle that and circle down here. And maybe maybe that'll help. So for the vertical asymptote, it's whatever makes the zero, whatever makes the denominator 0. Which is going to be 2. So I have a horizontal asymptote of -2. And a vertical asymptote of 2. And then you just draw your curve from there. Because your curves come close to the asymptotes, but they never, ever cross. Are we getting the sound fixed? Are we okay?
Yes, we've got it. Yes, we've got one fixed. A couple have logged out, and hopefully they'll come back.
Okay. All right. You think I should just keep plowing through or wait?
Yes, we can ask them if they have questions at the end.
Okay.
Yeah.
I'll try and leave some of it up so that they can see it. All right. Now, this number 6, I was talking to Miss Stone about this earlier. It's a little bit of a squirrelier one, kind of. It wasn't the easiest one to spring off with, that's for sure. But let's just take a look. On multiplication, one of the first things you want to do when you're working with the radical expressions is always think factor first. Always think of that. So on this particular one, on number 6, I look at it and I identify that I've got an M in the front here at the top in my numerator on my first term. Right here, there's an M. And then I noticed there's an M on the bottom, but it's in the second position. So what I did as my very first step is try to make those line up. So I went M minus 1 over negative, because every sign has a number and every number has a sign. So, so I just reworked that. And then for that particular one. And then I did my factoring. So on this one, I would I would just leave my numerator the same. And on the bottom, I'm going to probably write into this other one. I apologize for that. I'll erase it. But I'm going to take a -6 out. And if I take a -6m out here, that's going to leave me with m. And then I take a -6 out of a +6. That's going to leave me with a -1, which is the goal that I was looking for, because I want to be able to factor as much out as I possibly can. And then I have m plus 9 and then m minus 5.
I'm going to say no. Miss Sparks and I will be nice. There will not be one like number 6 on the test. But it is a concept that would probably be on an ACT or SAT. Just knowing that you can pull out a sign to make the signs match so you can work the problem. So it's a good little trick to know, and that's useful, beneficial. Wouldn't you agree, Miss Sparks?
Oh, yes. Yes, most definitely. Yeah. Miss Stone and I will not be cruel enough to put it on a test, but the SAT, ACT will probably do that. That's very, very true and very good point. So it's one of those things where you really need to have an eye for looking for those types of things. And I think for me, when I was looking at that, I always try to line up, like if there's a variable, I always want to make sure that they're leading. That's usually my concept. I mean, obviously in this case, there was only one that wasn't. So it definitely was important that they lead. Do you have a different approach, Miss Stone?
No, that's how I would do it too.
Okay. So now it looks a little cleaner since I cleaned that up, and I'm able to cancel those out. And my final answer was m plus 9 over negative 6 times m minus 5. But just since we're kind of talking about the SAT and all that good stuff, the answer key actually pulled this negative out and moved it to the top. And so it took the 6. So then the answer key actually says, you know, if we post this, it actually comes out and says minus m minus 9 all over a positive 6 times a m minus 5. So it moved my ferocious beast dog. It moved the negative sign. So the only reason I bring that out was I obviously, Miss Stone and I would accept this answer, but since we were talking about the SAT, ACT, it's probably a good idea to recognize that negative can appear in the numerator or the denominator. Don't you think that's good for them to know?
Yes, very good for the minimum. Yeah.
Because I feel like on a multiple choice test, such as the SAT or ACT, that's probably something that would happen. So y'all might want to jot both of these answers down and understand that they are really the same. It's just one has the negative in front of the 6 and the other has the negative with the m minus 9. I don't want to erase it until everybody's ready. Is everybody ready? The rest of them aren't quite that bad. That was the only squirrely one.
Okay, they're set. They're ready for you to move on. Yep.
All right. Since I wrote all over this, I'm going to try and get some of it off. All right. On the next one, do we have any volunteers to try and, there's nothing to factor in the first term. Do we have any volunteers to try and factor that second term? Is anybody writing anything down?
No.
No.
Yes, someone. Yeah, we have 9x times x minus 3. Good job, guys.
Good. Okay, so the top was factored as 9x x minus 3. Hey, Bill.
Yeah.
Would you mind taking care of
Did we teach for a while?
Yeah. Why don't you teach for a while and I'll take care of the dog.
What do we do?
She needs to go. She's crying to go out. Sorry, I have a whiny dog. Okay. So now what we'll do is try to cancel out factors. So I've got this factored. So I've got a 9x that will cancel with this 9x. That's a beautiful thing. And then this x minus 3 and this x minus 3 to cancel. So that leaves us, and when it cancels out, you're kind of, it's not completely canceled out. You are left with a 1, essentially. But so you've got all 1s on the bottom. Yay. And then at the top over here, we have a 6 left times 1. So your final answer is 6. Did anybody work ahead of me and did they get that?
We're getting some yes. Good job, guys.
Yay, good. Okay. Number 8. Anybody want to factor once again, the first term has nothing to factor, but that second term does have something to factor. Anybody want to?
Yeah, we already have an answer up there. Good job, Jake. K minus 5 times K plus 3.
Yay, good job. They're getting this factoring down. Okay, so what can we cancel here? Any guesses?
Awesome. K minus 5. Good job, guys.
Good job. Okay, so then that leaves us with 1 times k plus 3 for the top, and then k minus 7 times 1. So that we've got a k minus 7 on the bottom. You don't have to put those in parentheses. You can just leave them as is. It's just habit for me. But did we get some people that got that right?
Yes, they're getting them right.
Good. All right. So now for number 9, it's division. So you have to keep the first rational expression or irrational, and you want to flip the second. So some people, when they're doing this, will do factoring at the same time, but I caution you about taking too many steps at once. But in this case, if you were factoring, you would get 6 times n plus 2. And then n plus 2 on the bottom times, and then I'm going to flip this one right here. So it would give me n minus 4 over 1. So what can I cancel out here?
Good job. N plus 2. Good job, guys.
Good job. So that leaves me with 6 times n minus 4 over 1, or just that all by itself. You don't have to really put the over 1. So that's your final answer. Okay. On this one, we've got 2m over 7 times 4m squared over, because I want to keep flip change, 4m cubed minus 28m squared. All right. Nothing to factor in the first term, but the denominator in that second term, something can be factored out of it. What does that look like?
Oh, wow. We have some fast ones. 4m squared times m minus 7.
Good job. They're getting this.
They are. They're doing good.
So what can be canceled?
Good. 4m squared.
All right. So then that's going to leave us with 2m on the top. And 7 times m minus 7 on the bottom. And that's your final answer. Okay, number 11. Once again, it's a division, so you want to keep flip change. So we'll keep that first fraction, and there's nothing to be factored on it. And then the second one, $16p minus 40, and then 12p squared minus 30p. Okay, do we have anybody factoring?
Oh, that's quick. Okay, they have 4p minus 10. Again, make sure we're factoring completely. GCF on that one.
Okay.
So is there a common factor? There you go. So remember, if Sam, if you look at the 4p minus 10, you still have a GCF. They both share a 2. So it should be 8 times 2p minus 5.
Yes. But sometimes when you're factoring, if you don't see it right away, that will definitely happen. And all you need to do is then take that other factor out and multiply it, just like Miss Stone did just then. So what you would want to do, you recognize that says 4p minus 10. You're like, oh, I can still take a 2 out. So you would then just make it 8. And then 2p minus 5. There we go. And then the bottom one, you would take out what? Anybody got a guess on that one?
Yeah, they do 6p.
Yeah, 6p. And then you have a
saying 2p minus 5.
Good job. So here, there's a couple of things we can cancel. What are they?
Okay, I'm seeing they're saying cancel out the 8.
Okay.
Okay, and the 2p minus 5.
Okay, good job. Great. So then that leaves us with p plus 7 over 6p. And that's your final answer. Any questions? Now to the fun stuff, right, Miss Stone?
Oh, yes, these are always fun. Yay, functions.
Yes. And because everybody likes getting a common denominator. Okay. This is typically how I do it, Miss Stone. You let me know if you have a better way, because I'm always interested in a better way. What I typically do is when I know the denominator is not the same and I know I have to get a common denominator, I go ahead and rewrite my fraction with just a little bit bigger bar, knowing that I'm going to have to multiply the top and the bottom by the same thing in order to get that common denominator. And also over here, I'm going to go ahead and factor my bottom one while I'm writing it, just in case there's something later that I could cancel out. Do you do something different?
I don't do the long line, but I mean, that's a good visual to help them remember you're going to have more in the denominator.
Yeah.
I like it.
Oh, okay. All right, good. I have to do that to remind myself I've got more to do. The fun is only beginning.
That's right.
Okay, so what I do next is I take a look at both of my denominators, and I'm like, okay, I don't have anything about them that's the same. So essentially, I'm going to be using this denominator here and multiplying the top and the bottom because I can't change the value of the expression. So I have to, whatever I do to the top, I have to do to the bottom and vice versa. So I'm going to have to multiply the top and the bottom by 2 times x plus 3. Because this is what's going to make the numerator or both of the denominators the same, because that's what we're trying to get as a common denominator. So over here, to make this one common, I'll multiply it by the x minus 2, and I'll multiply the top by the x minus 2. Once again, because I cannot change the value of the expression, so whatever I do to that denominator, I have to do to the numerator. So now the next step for me is to do the multiplication at the top, and then eventually we'll add all of our like terms. But to multiply the top, this is 2 times 2, which is 4. And then I have to distribute that 4 to the x and the 3, which is going to give me 4x. And then the 4 times 3 plus 12. And that's going to be all over this big denominator that we created with all of our factors represented. I just put them in order there. And then I'm going to distribute this 5 to the x and the negative 2, which is going to give me 5x minus 10 all over this big denominator that we created. And then I'll combine like terms. So I've got a 4x and a 5x. So that's going to give me 9x. And then I've got a positive 12 and a negative 10. So that's, when I combine those, that's going to give me a positive 2 all over our denominator. And that's your final answer. Are there any questions popping up, Ms. Stone?
Nope.
Is everyone happy?
Who wouldn't be happy?
I know, we're adding fractions.
No, you can't get rid of the 2, Madeline. Remember, if it's joined together with a plus or minus, it has to stay together.
That's a really good question, and that can get confusing. And a lot of times what I do to remind myself that it's a term, and I didn't do this at the end, but a lot of times I put my final answer actually almost in a bracket. The only way that, I was going to say, the only way that you'd ever be able to get rid of a 2 is if a 2 factored out of your final answer. And I can't remember if we have one of those or not. Any other questions? Okay. I wish there was a way to clear this more quickly. And if someone knows more about Cami than I do, and you know of a way, please share it with Mrs. Sparks. I had somebody share with me the other day how to make a straight line on a graph. You can hold the shift key down, but I'm still learning. Okay. Number 13. So once again, what I try to do is just make those really long lines to remind myself I've got to make a common denominator. So I see that I can factor out here. So I'm going to give, it's 2m. I'm going to take a 2m out. That leaves me that. I'm not leaving myself. Well, thank goodness I only have to write another 2. So over here on this side, the only thing, well, actually, this, Miss Stone, you might want to help me out here and make sure I don't botch this explanation up.
Okay.
This too, because it kind of alludes to maybe Madeline's question a little bit. This 2 right here is represented over here and here. So I wouldn't have to multiply this denominator over here by this 2 because it's represented in both places. You're looking for terms that aren't included in both of the denominators. And the only terms that are like that are an m and a 5 5m minus 1. Do you have anything to add to that, Miss Stone?
Nope. Looks good.
Okay. So what I have to do at the top now is multiply this top part by everything that I multiplied the bottom by, which was an m and a 5m minus 1. And over here, I didn't change anything. It stayed pretty much the same. All I really did was factor it. But the 2 that was in that factored form is represented over here. So I don't have to do anything to this one at all. So this one was good. Now what I need to do, the next step though, is I have to multiply all of this stuff at the top in the first term. So 5m distributed to both the 5m here and the minus 1. So 5m times 5m is 25m squared. And 5m times a negative 1 is a negative 5m. And then I've got plus m plus 5 over here, all over this denominator that we created. And now I want to combine like terms. I have no other m squareds, so I'm just going to bring down my 25m squared. I do, however, I have a negative 5m plus m, which gives me 4m, a negative 4m plus 5, all over 2m times 5m minus 1. And that is your final answer. So one of the things that was kind of highlighted in this particular problem to me is the fact that when we factored the denominator in that second term, when we factored that from 10m squared minus 2m and factored it into 2m times 5m minus 1, when that got factored, we recognized that this 2 right here was in both of the terms, both that first fraction and the second one. So we really only had to work with the first fraction because that 2 was included in the second one. Anything you want to add to that, Miss Stone?
Nope.
Okay.
Just
Any
be careful
questions?
with the 2.
Okay. Is any questions? Is this helping? Is this making it a little more clear? It's a very detailed work, so you really do want to pay attention to details when you're going along and try not to skip steps, because that's where those simple math errors occur. And there's a lot of detail in this and a lot of places for that to occur. So just slow down, take your time, and write out each step. Okay, 14, right? Is that where we are? All right. So once again, my quirky little thing of writing the extra long line to make sure I've got room. I know that I can't factor anything out of that one. However, over here, I'm going to go ahead and factor this denominator to see if I can see what we have. Well, we don't have anything alike in these at all. So on this first one, I'm going to have to multiply everything in the denominator of my second term by the denominator over here. So, and whatever I do to the bottom, I have to do to the top as well. And over here, I've got to multiply the denominator by 3k minus 5. And once again, whatever I do to the bottom, I must do to the top. So now I'm going to start my multiplying. And I've got 6 times 6, which is 36. And then I have to distribute that 36 to both the k and the 1. So I've got 36k plus 36. And then I'm going to distribute this 4 to the 3k and the 4 to the negative 5, which gives me a negative 20 all over that denominator. Try and clean it up a little bit. Now I'm going to combine like terms. I've got a 36k here and a positive 12k here. So that's going to be 48k. And I've got a positive 36 minus 20, which is going to give me a positive 16 all over 6 times 3k minus 5 times k plus 1. Anybody recognize anything on that 48k plus 16? Is there something we could do? Did we get an answer?
They said you can take out a 6. You can factor.
Yes.
You can't take out a 6 though.
You
Be
can't
careful.
take out a 6,
You
but
can't take out a 6, but you can factor.
yes. And it will reduce, which is maybe what, I don't know. Because then they're going to end up with this. But they can reduce. This then would reduce. I'm running out of room, and I'm going to go off my little sheet. That's going to be k plus 1. But you can reduce this, and you could take a 2 out of that, which would leave you an 8 here and a 3 here. So your final answer would be 8 times 3k plus 1 all over 3 times 3k minus 5 k plus 1. So I think earlier Madeline had asked a question about something about taking a 2 out. And so in this case, there was a way to factor some of it out. And that's the only way is when it's a factor. I don't know if that makes sense to her question that she asked earlier or not. So that's your final answer. Should I keep working them? Or is everybody good? Should I?
Let's do one subtraction so they remember they have to
Distribute.
right, exactly. Yeah.
Okay. All right. Mostly what I need to know from them is this helping them understand this concept? What are the responses on that question?
Is this helping, guys? Yeah, they're saying yes.
Okay. All right. Is there any specific questions at this point, or just they like watching the examples because that's helping?
Any questions at the moment, guys? They're saying they like watching the examples. And
Okay.
they're ready to move on.
Okay. All right. Good. Just what I need to know. Okay. So on number 15, we're our first subtraction. So what we'll do on this one is I'll make my big old long line. And I've got b plus 2. And then for this case, I'm going to go ahead and put it in parentheses till I figure out what I'm going to multiply it by. That denominator down here, I can factor out a 2. So I'm going to take a 2, and that leaves me with 3b plus 2. Didn't mean to make that quite so long. And then minus, and then over here, I've got a 3 and a 2. And so I have to multiply this. There is no 3 all by itself. I know there's a 3 within that term, but there's no 3 all by itself. So I have to multiply this by that 3. And over here, I have to multiply this by the 2 and the 3b plus 2. So I have to do that at the top as well, because whatever I do to the denominator, I have to do to the numerator. And now we get to combine all this stuff together. I'm going to go ahead and write down my denominator that we've created. And then I'm going to distribute my 3 to my b plus 2. So that gives me 3b plus 6 minus, and then all over here, I've got to distribute. This is 2 times 2. And I'm going to make a big parenthesis here because I've got to distribute that negative later. This 2 times 2 is 4, and that 4 will then be distributed to both terms, the 3b plus 2. So that's going to be 4 times 3b, which is 12b, and then 4 times 2, which is 8. And now I've kind of run out of room down here. So 3b plus 6. And I'm going to write back up here at the top. Sorry about that, guys. 3b plus 6. And then this negative, just like Miss Stone was talking about, one of the reasons we wanted to make sure we did a subtraction one with you. This negative, it's like multiplying this by a -1. So it has to be distributed here and here as well. So you technically have 3b minus 12b plus 6 minus 8 for your numerator. So 3b minus 12b is a -9b. And 6 minus 8 is minus 2. And that's going to be all over your 2 times 3 times -9b minus 2. Oh, I see something that cancels. Unless did I write something down? No, I did write something down wrong. My bad. I was like, where did I get that? 3.
Yeah, I noticed that too. When we talk about, well, hey, it could be worse. You could be going to Detroit. Could be going to Detroit.
So that's your final answer. I'm going to circle it because it kind of got all mixed up in there. Does everybody see that okay? Did you follow it since I had to go back up at the top?
They're saying they're good.
Okay.
Yep.
Do they want to stay for two more?
We have yeses, so continue, Miss Sparks.
Okay. All right. Good deal. They're patient with me with erasing
They
them.
are. Well, I will say this. I remember teaching from K-12. It's not easy to write like that.
Oh, yeah.
Not at all.
I know. It's really not. It is a wee challenging. And it, you know, my students will tell you it's not like my handwriting on the board is stellar either. They're very patient with me, the sweet babies. Okay. All right. So now, once again, I'm going to draw my long line, but I think I'm going to go back up here so that because I seem to run out of room when I'm there. So if everybody can kind of follow along with me, I'm going to do number 16, but I'm going to go up here with it. So I draw my long line for n minus 4. I get a little overzealous with my line. And then, so, oh, this is a nice one compared to some of the ones we've had. So there's no 5 over here, so I have to multiply both the top and the bottom by a 5, because basically what you're looking for is factors that don't match. And then over here, we're going to multiply both the top and the bottom by n minus 4. All right. So what we would do is now we're going to multiply 20n and then write down our factors. Clean that up a little bit. And then I'm going to make a big parentheses. I'm going to distribute this 5n to both of the factors within this term. So 5n times n is 5n squared. And then 5n minus 4 is minus 20n. So now, just like we did in that other one, this subtraction sign has to be distributed to both terms in this second portion here. So I've got 20n minus 5n squared minus a minus 20n, which technically gives me a plus 20n. All over 5 times n minus 4. And so now when I combine like terms, I have 20n plus 20n. I hope that's okay that I'm erasing that, guys. So that's giving me 40n minus 5n squared all over 5 times n minus 4. And it looks like to me we can factor some things out. I'm hoping everybody's seeing that with me. Is everybody following along? So it looks like we can take a 5n out, and that's going to leave us with 8 minus n. And then that's all over 5 n minus 4. And then This 5 will cancel. We've got n e times 8 minus n all over n minus 4.
And we had a great question. Miss Sparks, can you scroll back to where we can actually see no, I can see the original problem.
I think it's here.
yeah, it is. I know I got lost. I was like, wait a minute, where did it go? I'm not sure if it's Samuel goes by Sam or not. So I'll say Sam. But he asked a great question at the very beginning where you have 5n minus 5. If you could go ahead and simplify that fraction. And on this particular problem, you could.
Yes.
Because it's within the same fraction, right? It's part of one fraction. So just be careful simplifying, because that's where we start messing up. Sometimes it's better to wait to the very end to simplify so we don't make a mistake.
Yes.
But yes, you could have, Sam, simplified the 5s right there and you would have gotten the same answer.
Absolutely. And I've thought about that about partway through. But just like you cautioned them, Miss Stone, it can get a little sticky about when you can and can't do it. So it's sometimes like you said, it's just best to wait till the end.
Right. I say my order is get the common denominator first and simplify last. That way you're not accidentally forgetting a rule.
Yes. And, and later on when you get really, really proficient and you've done a ton of them, you probably could get away with doing a little bit more than that. But I've known to get a little bit ahead of myself before and canceled something before I should have. And it can cost you. And as you see, these problems are, they're very detailed. And so you don't want to miss a detail early on. All right, the last one. So once again, take that first term, 2x, and then I've got 3x plus 5. Oh, this is a minus. Sorry about that. And then the second one is 5 over 2x cubed. So don't really have any matching factors. So I'm going to have to multiply my first term, both the denominator and the numerator, by the 2x cubed in order to make that bottom a common denominator. Whatever you do to the top, you have to do to the, whatever you do to the bottom, you have to do the top. And I'm going to have to do the same over here. And what was missing was the 3x plus 5. And this makes our denominators common now. So I'm going to go over here and multiply. I've got 2x times 2x cubed, which is going to give me 2x to the 4th. And this minus, well, I'm gonna go ahead and do this first. I'm going to multiply. I'm going to distribute my 5 first. You could, if you wanted to, and I don't know what your thoughts are on this, Miss Stone, they could do a -5 and distribute that to both. Or would you?
Yeah, they could do that.
Okay. All right. Then I'll do that. So if I take this and treat it as a -5 and I distribute that to the 3x, that's -5 times 3x, which gives me -15x. And -5 times 5 is -25. Did I miss anything? Oh, yes, I did. This was 4x. My 2x times my 2x cubed. I multiplied my x's, but didn't get my coefficients. That looks better. And then I'm just going to rewrite my long denominator that we created. And believe it or not, that's our final answer for that one. We're done. Are there any questions? How do you guys feel about all of these lessons at this point? And I would love to get your feedback also, if you don't mind, on Math Lab. So, okay, good. Glad to hear it. I really appreciate that. Oh, good. I'm really glad to hear that. Please come back. Please come back frequently and often. It's not that painful. It's been really nice to have Miss Stone in here with me. I will say that. That's been a blessing to have somebody tell me what people are answering. Okay. Well, we're doing the worksheet on Thursday. Some of the answers I'm seeing, the worksheet on Thursday is exactly like this one. And so we're going to be doing the same exact thing in Math Lab on Thursday. And then we're going to be doing something fun in class tomorrow to give us a little more experience with the adding and subtracting, because I know that that's probably the area that's a little shakier. Seems like the multiplying and dividing comes a little easier. But please email Miss Stone or I if you guys have any other questions. And thank you very much for showing up. Miss Stone, you got names of those that came?
I did write them down. Thank you guys for coming. And my advice, if you come Thursday, if you need to come back Thursday, is maybe try to work some of the problems before coming in, so you can kind of see what step you're getting stuck at. That might help us to see where we need to spend a little bit more time in class. So, but y'all did good. Thank you for coming.
Yes, thank you so much for coming. Y'all have a blessed evening. Bye-bye.
Bye, guys.
Yeah, I don't tell Jeff. I mean, Jeff, it's not really good for him to say, we'll call Bill and that, but we can't do anything about that. That's up to them. Yeah.
Oh, well, I think it went well. What do you think?
Yeah, I think so too. I can't believe you can't see their chats.
I know. It feels so awkward. And a lot of times I'll have a student that doesn't mind being the speaker. I'm sure they were all completely shy today. But a lot of times I don't have any, I'll have, so I can't really tell.
Right. No, I remember teaching at K-12, they never wanted to grab a mic. So I was always having to teach. I mean, I got used to teaching and reading at the same time, just to make sure I was answering their questions. But yeah, I can't believe you can't see the group chat.
Well, like right now I can see the group chat,
right?
But it means I can't write on the screen.
Oh, goodness.
I know. Yeah.
Well, it's pretty much one of those things where it probably is helpful to tag team when we can.
Yeah. It really is. I mean, I really appreciated it, and, I'm just like, and it feels so awkward, the pauses when I'm trying to erase and do all of that stuff. I'm just like, I try to do filler when I can, but, sometimes when it's just one-on-one,
So is this the most you've had, 14?
Yes.
That's pretty cool.
Yes, definitely. And what I wonder with the ones that couldn't hear, I wonder, was it the logging out and coming back in?
I'll ask them tomorrow. They're my students.
Okay.
So I will see what they did to see what worked.
Okay. Because what I'm thinking, when that happens, sometimes maybe two people are hitting at the same time.
That makes sense.
That's my only guess about it. But yeah, we had 14. That's amazing. And I just feel like since we made it mandatory, and I feel like this has been a good week to make it mandatory because it's a week. But I also think maybe it will take some of the like, oh, what's Math Lab really like?
Right. Wonder if like from here, I don't know, like if they would get mad at us, but like wonder if we could say you have to come to 2 math labs per chapter.
Yeah. Yeah.
I mean, because I could give them if they needed help a day before a quiz or a day before the test. That would be their 2 days. So it
Yeah.
doesn't matter when you come, but you have to come 2 days to the math lab per chapter.
Yeah. Or, you know, and even maybe the first time we tell them that, we'll say, we'll give you 5 points extra credit too, or that'll
There
be,
you go. Yeah.
that'll be the bonus, or 2 points extra credit, or whatever you want to deem it to
Okay.
be.
All right. We'll do that. We'll add that to the lesson plans of the next chapter.
Okay.
So
So,
it's in writing and they'll kind of, we can just see how it goes. I mean,
yeah.
we don't want to hurt anyone, but if they'll come, that's what it's about, you know.
Yeah.
Them
And it
getting
was really nice to have this specific lesson, you know, which obviously we could, you know, I can always do their homework, but it's always nice because I was able to design this, and I probably will design it where there's even more room.
right.
But I was able to be knowing that I was going to do this, you know, to try and give myself some space on the PDF. So anyway, here we go. So I'm anxious to see how your kids are in class tomorrow.
Yes, me too. And to give them, and hopefully they'll give the other kids that haven't come yet feedback.
Yeah.
You know how so, but like I said, you'll be swamped on Thursday.
Well,
So,
not though.
yeah, but hopefully they'll split it up, and you'll have some, you know, half the 11 o'clock hour and 4:30. But I can come at the 4:30 time again
Okay.
to help you out.
Okay. Sounds good.
So,
All right. Thank
alrighty.
you. All
You're
right. Have a
welcome.
good
Bye.
tomorrow.
You
Bye
too.
bye.